do you have like a final review, or should we just go off of all of the other exam review sheets that you've given us?
Yeah, so the final exam review will be, yeah, just go off the review. Am I sharing my screen still? I think I am. Can you see this?
Yes.
So yeah, basically, if I go to assignments, yeah, so all the reviews I've previously posted are excellent reviews.
Okay.
So you can go through all 5 of those. You can also review your old exams.
We never got the paper version of exam 3 back because Corona.
Yeah.
Can you like scan like a sheet of the exam 3?
Oh, scan them and email them to you? That's a good idea. I hadn't thought of that. Yeah, I can do that.
Thanks.
I'll do that. So I will scan them and then just check your email. That's a good idea. I didn't know how to get them back to you, but I didn't think I should have thought of scanning them. It'll take me a little bit of time, but yeah, I'll try to do that as soon as I can. I can probably do that today. Because that problem is sending the emails is going to take some time, but I will. I wonder if I can attach it to this. I think I can. You know what? I'll do that. When I will go through the speed grader here, and I will just attach it as a comment to your exam. I'll do that. That'll be the easier way. So check your exam 3, and I will upload your exam with it graded. Good suggestion, Rachel. What other comments and questions do you have? You know what? Let me see something here. I'm going to stop sharing for a minute. Oh, I did. I know that we had passwords on those other exams. Let me find those really quick. So just write these down. I'll tell you what they are. If I can find it. Oh. I know that the password for exam 3, so there's no password for exam 4. The password for exam 3 is BR, the number 3AK. Apparently, I didn't write down the other 2. Those are going to be harder to look up.
Are any of say that again?
Break, BREAK, except for instead of the E, it's the number 3, BR3AK.
And are any of them capitalized?
No, they're all lowercase.
Okay, thank you.
The other 2 exams are going to be really hard. Well, maybe it will not so hard. Let me look.
I think the one for the first exam was Go Jazz with a 0, and then for second one it's February.
Oh, good job.
I'm pretty sure. I think I think.
Usually write that down. And I didn't write it down this time. I can look it up though, but that sounds right. I would go, especially the Go Jazz one sounds right. Which exam was that for?
1.
Was number
Yeah,
1?
the first one.
Yeah. I remember like writing it down somewhere. I just don't remember.
Okay, exam 2 is the one that you think we don't know. Exam 2 was February with a capital F. You're right. Good job. I'm in right. Okay. And exam 1, just to double check. Yeah, it was Go Jazz with a 0. Okay.
Any capitalizations on those?
The capital February, capital F, but everything else is lowercase.
Okay, thank you.
Okay. What other questions do you guys have?
I keep putting my p-value like less than or greater than in the wrong direction, and I don't know what I'm doing wrong, but I'm definitely messing it up. So could you explain that a little bit?
Okay, so the best thing to do is to draw a picture. Okay. So if I'm drawing a picture here, generally we're talking about a normal curve, although it doesn't have to be normal. It could be here. Actually, here I will draw a purposely not normal curve. So let's pretend this is our chi-square distribution. Okay. Now, by the way, I will say this. I was noticed on a couple of the tests, and I haven't graded a lot of them, but on a couple of them, remember that it's always the right tail test. You're always supposed to be measuring the right side on the chi-square. Okay. It's always, so basically, and I know it's a little bit different. So let's talk about chi-square. So remember, it's independent versus your alternative, which is not independent. Okay, and then so variable 1 is independent of variable 2. Variable 1 is not independent of variable 2. Okay. So with the chi-square, it's always right-tailed because if the observed equals the expected, then the sum will be close to 0. Okay. So now I know that with the chi-square test, typically we're going to say on a null hypothesis that either p or mu equals some number, whatever the number is. And your alternative hypothesis could be anything. With a chi-square test, you can think of it as, so the chi-square test is always going to be greater than whatever the number is. Okay, so if you want to think about it, chi-square test is always a greater than. It's always a right-tailed test. Always, always, always. For our class. I won't say that for other classes, but in our class, chi-square test is always going to be greater because we're always comparing our observed to our expected. And if we get a large sum, then that means we got something that we didn't expect. And so that it's always a right-tailed test, okay? So as far as if you're talking about a regular, either a normal distribution or a t-distribution, because in both cases they're symmetric, okay? So you need to look at what's going on with your alternative, okay? So if the alternative is less than your p or mu is less than whatever your number is, that's going to be a left-tailed test. If your p or mu is green, we'll make it this time. If it's greater than, then you're going to get the right-tailed test. P or mu greater than whatever your number is, it's going to be a right-tailed test. And if it's two-tailed, then you're going to need to double. If it's two-tailed, then pick a tail and double it. Now, I will tell you, I know there was a test question. I don't remember the exact numbers, but let's say, I think that the null, I'll just make up something, because this can be, this was a little, there was a test question that was like this. It was probably a little bit confusing. So you had, I'm just going to make it up, mu equals 7, let's say. And you had the alternative hypothesis was mu is greater than 7. Okay. Now the funny thing was, is when you did the test, you got x bar was equal to 5.5, let's say. Well, you could probably look at that and say, well, if I got an x bar that's 5.5, clearly that's not greater than 7. So you could probably right off the bat say, do not reject the null. Clearly you got a value that was less than 7, so why would you think that was greater than 7? Now, in this case, here, this one was a little bit tricky because if you didn't draw your picture right. So let's assume it's normally distributed. So I've got my normal curve here. Sorry, draw it again. Okay, so in this case, we've got a mu equals 7. Okay. Now my x bar, surprisingly, was lower than that. So I got my x bar equals 5.5. Now normally you would say pick the tail, but in this case, because my alternative hypothesis said it was greater than 7, instead of shading the left side, I want to shade the right side. And so I don't know what your p-value is, because I'm just making this up, but your p-value, I can already tell you it's going to be greater than 50%. So I'll just make it up. So that's going to be 74%. Let's say your p-value is 0.74. Okay. The wide area in this case, your p-value, so a lot of people would have given me the left side, which would have been 0.26. The p-value in the white is 0.26 rather than 0.74. So this one was a little goofy in the fact that, and that's, well, and I will say this is another reason why if you do a two-tailed test, if my alternative had been mu does not equal 7, that saves you for when you get a strange value you weren't expecting. You were expecting it to be greater than 7, but you only got 5.5. In this case, I wonder if this is going to let me draw this properly. If I had used this as my two-tailed test, then I could have taken my p-value of 0.26 and I could have doubled it, which would have been a p-value equals 0.52. And in that case, I would have been shading both of the tails black. Hopefully this is going to work. Oh, it did. It worked right. And so the black area would be, in this case, 0.52. And so that's why, in most cases, we do a two-tailed test rather than a one-tailed test. Because if you get an answer like like you were expecting it to be greater than 7, but you got 5.5, this is a better alternative hypothesis than this is. So does that make sense, Tori?
Yeah, that does make sense.
Okay. So, and I will tell you what, in the real world, except for the chi-square test, which is you can think of as a greater than, almost all other tests are going to be two-tailed tests. The chi-squared is the exception. Chi-squared is always going to be a right-tailed test, but almost all other tests are going to be two-tailed in the real world. For this very reason that if you're wrong, it kind of covers your butt a little bit. Okay. All right, so what other questions do you guys have?
How do you best recommend studying for the final? Like, what things do you want us to do? Like, is there a review, or do you just want us to go over the test?
So yeah, like I said, the previous reviews I think are good. I would go over your previous reviews. I would go over your old tests, both of the computer and the written. So I just gave you the passwords for all the computer, and I will scan in the written for test 3 after class today, so you can look at that. So those would be my biggest. Also your quizzes, those are good too. So you can look at the old quizzes.
Is there a computer portion to the final?
Yes. So our final is Tuesday. What day is that? 21st, 28th, Tuesday the 28th. The written portion will be just like the other one was with Proctorio. It's an hour earlier than our regular class. It's 9 to 11 a.m. And so if you submit it by 11 a.m., I'll give you an extra 5% on the written portion. And the computer portion, it's all day. You can take it anytime you want during the day. You can use your formula sheets like you've always used, and nothing else. And Excel. Well, Excel, you can use Excel for the computer portion. The written portion, no Excel, but you can have your calculator. So, any other questions? I have some questions for you, because I know that this was kind of a, this is my math 1050 final, if you want to look at that. Because I know that there was a question of a problem of interpretation. Oh, sorry, my phone's ringing. Hopefully my wife gets that. That's really loud. I apologize. There we go. She got it. So let's say that I have a null hypothesis. I'm going to do a couple of scenarios here. I want to make sure you guys interpret this properly, because I know that this is really the hardest part of both exam 4 and the final project. Okay, so I've got a mu equals 26, and I've got an alternative hypothesis of mu is less than 26, and I have a p-value that equals 0.23, and I've got an alpha equal to 0.05, and I have a 95% confidence interval of, I gotta make up a bunch of numbers here. How about 24.5 to 28.5, let's say. I'm just making these numbers up. Okay. So the first question is, question 1. What is your conclusion based on hypothesis test. Question 2, what is your conclusion based on the confidence interval? And do they agree? I'm going to ask those 3 questions because the interpretation is clearly the hardest part of this.
For the hypothesis test, there's not enough evidence.
For the hypothesis test, what?
There's not enough evidence.
There is not enough evidence that.
I don't know what this is about.
Okay, well, just give what you can. That the mean.
That the mean is less than 26.
Is different, is less than 26. Okay, good, that's good. That was correct. Okay, so what would be your conclusion on the confidence interval? And when I say that, could you say this? Didn't mean to do that. Could you make the same conclusion based on the confidence interval?
You couldn't because 24 is below 26. So that's all I know.
Okay, so you say that this is a false conclusion based on the confidence interval?
Yes, but that is an educated guess.
Okay. Do you guys agree with Caitlin?
Yes.
Okay. So the answer is should have been no. You can make the exact same conclusion based on this. There's not enough evidence that the mean is less than 26 because when you're looking at your confidence interval, 26 is in here. So there's not evidence that it's different than 26.
So I don't know if I was right or wrong.
So you were correct on question number 1. You were incorrect on question number 2. So you can make the same conclusion. So there's not evidence that the mean is less than 26 because 26 is in my interval. There's not evidence that it's less than 26 here either.
So if I had like 24 to 25, then that would be, there is enough evidence.
So if this was 24.5 to 25.5, now there is evidence that the mean is less than 26 because both of these numbers are less than 26.
Okay, what if both numbers were bigger than 26? There is not enough evidence.
So 28 to 30, let's say. Is that evidence that it's less than 26?
No, so it's not enough evidence.
Okay, so that's kind of a silly. So it's kind of a silly conclusion because now I would say that so based on the confidence interval, there is evidence that the mean is greater than 26.
Oh.
Right? Because both of these numbers are greater than 26. Now, our alternative was looking at less than, but based on the confidence interval, not only can we say it's not less than, it's greater than, because both of those numbers are greater than 26. So this if these are the numbers, this would actually be a better conclusion. Okay. This is all you could say based on the hypothesis test. It's not less than, but with the confidence interval, you could say not only is it not less than, it's greater than. Does that make sense?
So it's not a question of there is enough or there is not enough. You just sort of change it to fit what it says, basically.
Yeah. So in this case, if this is my interval, we've got evidence that it's greater than 26. So this is a better conclusion than this, assuming all these numbers are correct. Does that make sense?
Yeah,
Now,
this was confusing. Oh, sorry.
Oh, I know it was confusing. That's why I wanted to go over it again. Now, based on what I have written right now at this moment in time, do the confidence interval and the hypothesis test agree?
I think so.
This one's really a tricky one because this is really contrived. So we're saying there's not evidence that the mean is less than. We're saying that the mean is greater than. This one's kind of arguable, but we kind of we made this up. So I would never give you a question like this on the test. Let me go back to the original question. The original question was 24.5 to 28.5, right? So the original question, we said that there was not evidence that the mean is less than 26. We said that the confidence interval told you the same thing. Does this agree?
Yes.
Yes. Yes, these agree. Okay. Now, based on if I change this to 24.5 to 25.5, do they agree?
There is enough evidence that the mean is less.
So yes. So the confidence interval says there is evidence. The hypothesis says there is not enough evidence. So no, these do not agree.
Why would the hypothesis test change? Because the p-value is still 0.23.
Yeah, well, I haven't done anything to the hypothesis test.
Oh, I see.
So
Yeah.
should it change in real life? Probably, but here's my issue that happens. Okay, let's say that the person did the hypothesis test correctly, they did the confidence interval wrong. Okay, well, based on this, these do not agree. Now, there is a rare case where you do them both right and they don't agree. It's really rare though. But so assuming that I did these correctly, no, these don't agree. Now, I think on the test, on the last test, if I change my confidence interval, so let's say that I keep my alpha at 0.05, but I do a 90% confidence interval, that might be a reason why they do not agree. And I think that did happen on the last test. But if you're using the same alpha for both, if they're both 5 and 95%, they should agree unless you make a math mistake. And if you make a math mistake, then in this case, these do not agree. So I know this interpretation is tough, and that's kind of why I'm going over this. But based on what I've written here, based on these numbers right here, these do not agree. Does that make sense?
Yeah.
Okay. Now, let me change this to another one. Let's say that I have P, we're going to make P, or we're going to make this P equals 0.26, and P less than 0.26. I get a p-value of 0.23, alpha is 0.05. We're going to change all of these numbers here to decimals. Okay, I'm going to erase this, and I'm going to erase this, and I'm going to erase this.
If you have a 95% confidence interval, wouldn't your alpha be 0.025?
No, that kind of goes back to this thing here, okay? So if I'm doing a confidence interval, that this green and black one is probably the rest, okay? So this side is alpha over 2, and this side is alpha over 2. And if you add those together, alpha over 2 plus alpha over 2 equals alpha. Okay, so essentially if I'm doing it, so if I've got 95% here, I've got 2.5%, 2.5% here, and I've got 2.5% here. So in this case, your alpha is going to be 5%. Does that make sense, Tori?
Yeah, that makes sense.
Okay, so it's the same thing. All right, so I've changed the letters. Basically, most of the numbers are very similar, but I want to see, based on all this stuff, okay, what is your conclusion? So P is your probability of success. So what is your conclusion based on this? Based on the hypothesis test? So here, let me write this down. There is or is not, you have to tell me whether there is or is not evidence that the proportion is less than 0.26. So is it is or is not?
Is not.
Is not. And the reason why it is not is because?
Because p-value is greater than alpha.
That's right. P-value is greater than your alpha. Okay. Now, the next question is, based on the confidence interval, can I make this same conclusion? Is this a correct conclusion based on the confidence interval?
Yes.
The answer is no.
Because aren't they both below 0.26?
That's correct. Both of these numbers are below 0.26. So do these agree?
They do not.
They do not agree. Okay. Now let me change this. Let's change this to 0.265. Hypothesis test doesn't change, correct? Because I didn't change any of those numbers. Okay. Now, based on the confidence interval, is this a correct conclusion?
Yes.
No. There's not enough evidence that the proportion is less than 26 because 26 is in here. So you're comparing, even though you don't need a null hypothesis for your confidence interval, we're still comparing that to this. 26 is in there, so there's not evidence that it's less than 26 because 26 is in there. So do these agree now?
Yes.
Yes, they do. These now agree.
So they both have to be below 0.26 to say that there is enough evidence?
When you say they both, what do you mean by they both?
The upper and lower confidence
The
interval?
upper and lower have to
They
both
both-
be below 26 in order for you to
It to be
conclude
considered.
that the alternative is true. That's
Okay.
correct.
Perfect.
Okay. Who else is here? Faith, do you understand what's going on?
For the most part, I don't know. It gets so confusing because
It
like
is confusing.
I
This
like just
is
the
the
language
absolute
is
hardest
so
part of statistics. This is why people hate statistics, is because of this very thing.
Yeah.
It's
and
hard.
I just keep getting everything confused, and I never know if I like, oh, well, we do reject or we don't reject, or if I say it's like, well, there is evidence
Yeah.
or there's not, you know.
This is, and I just want you to know that when I learned this for the very first time, clear back in the 1990s, it was hard for me too. So this is hard. How about you, Waverly? Are you getting it?
Yeah, I'm getting it. It's
Okay.
hard, but if I take time to think about what it's really saying, then I get
Yeah.
it.
So watch this video over and over and over this weekend so that you can get this right, because without question, and what's frustrating to me is that people will do all of the math correct and then they get this stuff wrong. But it's hard. I mean, I understand it's hard. This is the interpretation part that is hard. But it is frustrating when it's like they did the math right, but they don't know how to interpret it. So yeah. But I completely understand it's hard, and I empathize, and I know that it's hard. Okay? Do you want me to do one more of these?
Yeah, and also on the written test, there are like a couple problems. I have no idea which ones there were, but like where some of like most of the time there wasn't like a standard deviation given, so I like just had no idea how to do them.
Okay.
Or like the Z test or like the T test. And I tried like using different formulas and stuff, but I couldn't make sense of it.
Okay. So if you have a question about the test, I'm more than happy to go over the test, but I don't want to record that.
Oh, okay, gotcha. Sorry.
And no, we can do that. And in fact, I can stop the recording now if you want, and we can go over that, because I have a feeling that if you missed it, other people are going to have the same question.
Okay. Well, we could just like make up a similar question, maybe.
Okay. Well, without looking at the test, it's hard for me to know what it was.
Oh,
so,
okay.
I can do a good guess, but I don't. It would probably be better to do your test, and then you'd also have to tell me if you wanted me to show your test to everybody, or not, or better yet, tell you what. Is everybody cool if we stop recording because we're going to go over a test? Or would you like to keep recording? I mean, we've only got 10 minutes left anyway. How about we stop, we're going to stop recording, and then, and I don't remember, I can't tell your voice. Here, I'm going to stop recording.